Hi friends. Okay, today we will be starting the last part of wave optics or physical optics. Okay, last part, that is part 3. Part 3 of wave optics. So we will be starting part 3 of wave optics. Okay, so in part 2 we studied about the experiment regarding diffraction. That means I told you total bending of light rays after meeting any obstacle. So that itself proves that light is traveling in a not in a straight line but in a wave nature. That means after meeting the obstacle, the light totally bends away and it encroaches into the shadow region. That is the main definition of diffraction. Now coming to the experiments, that is regarding single slit experiment. Single slit experiment. As I told you, slit means just taking a cardboard and making a small scratch with a blade. That is called as a slit. That means when you are making a single slit, what happens? Lakhs of, thousands of, crores of sources of light will be coming outside. Not like YDS experiment. YDS experiment, you have taken two slits, two holes, S1, S2. So source 1, source 2 is coming. Only two sources are coming. But here in the single slit, lakhs and crores of sources of light is coming outside. Therefore here, what happens is slightly different in the case of diffraction experiment. That means in your before experiment in YDSC you have seen lambda, 2 lambda, 3 lambda, n lambda was the path difference for bright bands. Okay, these are the things. And for dark bands, you have seen lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n minus 1 into lambda by 2. These are the things you obtain for the dark bands. But here it will be different because there are only two slits. But here single slit with lakhs and crores of sources of light coming outside. So therefore, for example, chinna example cheptanu meeku. Suppose if you take 1 to 100 between the slits. Just example. Right, sorry for the disturbance. Small power cut is there here. Okay, let us start the chapter. So as I told you, in single slit, in YDSV experiment you have two slits, two holes, two sources of light are coming. But here, if you take in single slit, what are thousands, crores, lakhs of light rays will be coming outside. For example, if I take between the first one and second one, if I take difference is 100. Okay. Now, here it will be different. See, whatever bright band we got in YDS experiment, now it will become dark. Whatever dark band we got there, now it will become bright bands. I'll try to explain a small one. Now for example, take lambda. For example, between 1 and 100 source, if the difference is lambda. Between 1 and 100 source, if the difference is lambda, and this is for bright in YD experiment, YDSC. But it will become dark here. I'll show you how. See, between 1 and 100, the distance is how much? Between 1 and 100 source of light, distance is 100. Divide into two halves. Let me divide into two halves. And 1 to 50, 50 to 100. So between 1 to 50, distance is how much? Lambda by 2. 50 to 100, distance is another lambda by 2. So lambda by 2 indicates dark bands. That means between 1 and 50 source, you can see the distance is lambda by 2. So between 1 and 50, how many sources of light are there? You can take 2, 3, 4 second light and 52. Second and 52. Difference is 50. Third light 53. Difference is 50. Fourth and 54. Difference is 50. So like that, if you see the difference between any two bands, it is maintaining lambda by 2. That means it is indicating the dark band. It is indicating the dark band. That means whatever you assume the path reference in bright in YDSC, now it has becoming here dark band. In the same way you can explain for the next things also. For example, see, the same thing I can explain for next one, 2 lambda. For example, 2 lambda is there between, see, for example, between 1 and 100 source of light, this is how much? Say 2 lambda for second bright. Now this will become second dark here. How I will show you? 2 lambda I will divide by 4. Again you can see lambda by 20 and 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. That means I am dividing 100 by 4. In other words, 100, that means how much? 25, 50, 75, 100. That is what happens here. This is the first source of light. This is 25. Okay. So what happens here? Between second light, you have to maintain 25 and 27. 27 light. What is the difference? 25. Okay. The same way third light and 28. Again 25. So like that, if you see the light rays between the any two light rays, the distance is maintained as 25. Just as an example, I am telling you how to explain why this bright is becoming in here as a dark band in diffraction. So in this way you can explain the next case. Same way you can explain for 3 lambda, 4 lambda, etc. also. Okay. So ఈ విధంగా మీరు 4 lambda కావాలంటే ఏం చేస్తారు? ఇది సెకండ్, ఇది థర్డ్. ఓకే. 3 lambda ఏం చేస్తారు? Divide by 6. 2 lambda by 2. So like that, when you divide it, again it is becoming dark band. Okay. Clear? So whatever bright are there, lambda, 2 lambda, 3 lambda, 4 lambda, n lambda, these are becoming as first dark, second dark, third dark, fourth dark, and at the dark bands or fringe widths are formed in diffraction. Okay. So I told you in the experiment also, I will once again tell you. In the experiment in YDS you have taken 2 slits. Okay. But here we are using only single slit. This is the central one. This is screen. And this is the distance, capital D. As usual, capital D is very much greater than small d. Distance between the single slit here. S1, S2. Here I will take the distance as A. There I have taken D. Here I will take as A. And it is A by 2, A by 2. This is central band. Okay. So this was the light coming. This is from center. This was angle theta. Another parallel line we have assumed here. So here once again one more light ray meeting here. This is angle also theta. We have dropped a perpendicular here named M. Okay. And this was total 90 and this was 90 minus theta. And this was theta. So this displacement, whatever we called as delta x. So here it becomes what? It becomes not d sin theta, it becomes a sin theta here. Because distance between the slit S1, S2 we have assumed as a. In there YDS you assumed as d. So a sin theta avutundi delta x. Now here what happens? A sin theta becomes equal to what? The path reference, first one, for first dark, lambda. And sin theta is equal to lambda by a. And as I told you, this distance capital D is very much larger than small d. When it is very large, what happens to the light rays? Almost it is very small. That means angle is very small. So sin theta can be almost equal to theta. Therefore, theta for first dark is equal to lambda by a in diffraction. In diffraction, first dark, this is central bright, kada? central bright, first dark. Okay na? Like ikkada first dark, that's the first bright. Okay na? Ikkada first bright, dark bright, mali dark, second dark, mali bright, dark, mali bright, dark. So like this patterns you'll be getting here. This side and this side patterns. So this is for what? And this angle is also called as what? What is this angle? Okay? This angle is nothing but whatever angle it is indicating here. Okay na? That is theta 1d is equal to lambda by a and అర్థం ఏంటి ఇది ఇక్కడ పాయింట్. This theta is what? Angular width కూడా చెప్పొచ్చు అప్పుడప్పుడు, లేదా angular position. Theta is also called as angular position. Please, that is better. Angular position for first dark. In the same fashion you can find it for second one. Theta for second dark ఎంత అవుతుంది? 2 lambda. అలాగే థర్డ్ డార్క్ 3 lambda. అలాగే ఫోర్త్ డార్క్ 4 lambda. nth డార్క్ n lambda by a. nth డార్క్. Clear? Because we know 2 lambda ఇక్కడ 2 lambda పెడితే ఏమవుతుంది ఇక్కడ 2 lambda. Sin theta is equal to 2 lambda by a. So all these angles for first dark, second dark, third dark, nth dark are, what are those? Angular positions. Angular positions for first dark, second dark and nth dark. In the same way, we have assumed this distance as y, this point P, to this distance central point and 2. And in this triangle you can see into the P, S1, S2, N. NP, NP, ఇదేంటిది M dash అనుకుందాం. M dash. In this triangle what is tan theta? Opposite by adjacent. As I said, when the angle is very less, sin theta is equal to tan theta. So this is equal to what? Sin theta. So y by d is equal to, for first dark ఎంత అవుతుంది? Lambda by a. That implies lambda d by a is equal to first dark in diffraction. Lambda d ఇదిగోండి, lambda d by a is first dark. అలాగే second dark, this is also called as width. Okay, angular width, this is also called as width, angular width, లేదా సింప్లీ విడ్త్ అనండి. యాంగులర్ ఎందుకు, థీటా లేదు కదా, విడ్త్ అనండి. విడ్త్ ఆఫ్ ద ఫస్ట్ వన్. ఓకే, విడ్త్ ఆఫ్ ద ఫస్ట్ వన్ ఇన్ డైఫ్రాక్షన్. ఫస్ట్ డార్క్ విడ్త్ ఆఫ్ ఫస్ట్ డార్క్. అలాగే సెకండ్ది ఎంత అవుతుంది చెప్పగలరా? 2 lambda d by a. థర్డ్ది 3 lambda d by a. ఫోర్త్ది 4 lambda d by a. nthది n lambda d by a. And observe carefully the difference between any two width is equal to what? చూడండి, for example ఇది second one y second dark minus y first dark. We'll try to find out. 2 lambda d by a minus lambda d by a. What is LCM? A. 2 lambda d minus lambda d, that is lambda d by a. So here also we are getting again same way, lambda d by a. అదే విధంగా ఇక్కడ కూడా చూడండి, యాంగులర్ పొజిషన్ బిట్వీన్ ఎనీ టూ యాంగులర్ పొజిషన్ 2 lambda by a minus lambda by, that is lambda by a. This is angular position or angular width. It is also called as angular width. This is angular width between any two dark, second first, third second, fourth third. This lambda by a is constant. Lambda by a, angular width. Okay, so this is how you are getting for dark bands in the diffraction pattern. Very, very, very important things. Now we will go for bright. How we will get bright? Bright check chedam. See, as I told you, there is a small difference between YDXT experiment and this diffraction experiment. Entadi okasari check chedam. Have you copied all this? Yes. Now that small difference I will try to explain now. ఓకే, చూద్దాం ఆ డిఫరెన్స్ ఏంటనేది. నౌ ఇన్ వైడిఎస్ ఎక్స్పెరిమెంట్లో డార్క్గా ఎక్కడి నుంచి స్టార్ట్ అయింది మనకి? λ/2, 3λ/2, 5λ/2, 2n-1 into λ/2 ని స్టార్ట్ అయింది. కానీ హియర్ ఇఫ్ యూ స్టార్ట్ ఫ్రమ్ λ/2, వాట్ హ్యాపెన్స్? దిస్ λ/2 is indicating for dark. So what we'll do is we'll start from 3λ/2 from experiment. 3λ/2, 5λ/2, 7λ/2. Here what happens? 2n+1 into λ/2. Because if you put 2n+1 -1 పెడితే ఇక్కడ 1 పెడితే λ/2 వచ్చేస్తుంది. లేదు, this doesn't come in diffraction because now we are trying to explain for bright bands in diffraction. Bright bands in diffraction. So it is slightly different. If you start from here, it won't come. You have to start from here. ఇప్పుడు n ప్లస్లో 1 పెట్టండి. 2 into 1 plus 1, 3λ/2. 2 పెట్టండి, 2 to 4 plus 1. Now the pattern is right. So what happens here now? 3λ/2, 5λ/2, 7λ/2, 2n+1 into λ/2 is the pattern for bright width, bright fringes or bright bands in diffraction. Okay, and as you know, same thing. What is the delta x here? A sin theta is equal to first one. What is the first one here? 3λ/2. So what is sin theta here? 3λ/2a. So again, once again, if the angle is very small, what happens? Theta for first bright is equal to 3λ/2a, because sin theta is equal to almost theta, and it is also equal to tan theta, because I told you this capital D is very much greater than small d. మీకు అర్థమవుతుంది ఇక్కడ. సో ఫస్ట్ బ్రైట్ ఎక్కడ ఫామ్ అవుతుంది? 3λ/2a యాంగులర్ పొజిషన్. అలాగే సెకండ్ అది ఇన్ డైఫ్రాక్షన్ 5λ/2a. అలాగే థర్డ్ బ్రైట్ 7λ/2a. Observe carefully here also the angular width between any two bright. For example, second bright minus first bright, angular width ఎంత వస్తుంది చూడండి. సెకండ్ బ్రైట్ ఎంత? ఇది సెకండ్, ఇది 5λ/2a minus 3λ/2a. 2a LCM, 5λ minus 3λ, that is 2λ/2a. Again same, we got λ/a. అక్కడ మీకు ఇందాక ఎలాగైతే డార్క్ బ్యాండ్స్లో వచ్చే వాల్యూ యాంగులర్ విడ్త్, సేమ్ థింగ్ యూఆర్ గెటింగ్. దిస్ ఈస్, యూ కెన్ సి యాంగులర్ విడ్త్ బిట్వీన్ ఎనీ టూ బ్యాండ్స్, ఐదర్ రెండు బ్రైట్ అవ్వచ్చు, రెండు డార్క్. ఇట్ ఈస్ ఈక్వల్ టు వేవ్ లెంత్ బై డిస్టెన్స్ బిట్వీన్ ద స్లిట్స్, λ/a. Clear? So this is how you can explain. The same way you can give the other formula also for this one. ఆ ఫార్ములా కూడా ఇచ్చేస్తాను. As I said, the angle is very small. Sin theta is equal to tan theta కదా. సో ఆ ఫార్ములా పెడితే అక్కడ ఏమవుతుంది అది కూడా చెక్ చేద్దాం. ఫస్ట్ వన్ 3λ/2a is equal to tan theta, that is y/d. అప్పుడు ఏమవుతుంది? 3λD/2a. This is first bright. Okay na? This is for first bright. Next one you can write down easily. 5λD/2a, second bright. Next third one 7λD/2a is third bright. Okay, so this is how we have to derive the equations in the diffraction experiment. Okay, clear? Note down please, very important this thing. So if you don't understand this, you can't go forward. Very important concept also, this angular width. Okay, angular width and also the continuous values what you got. Okay, only thing is a small difference between YDX experiment and this one is, there whatever you got bright, you are getting here dark. Okay, and dark you are getting bright here, and the difference already I have shown for you. And this is how you have to perform the diffraction experiment. And please make a note in the examination, they will be asking angular width. Theta is called angular width between any two. Between any two, either bright or dark. See, bright aina, dark aina, you are getting same lambda by A only. Just now you have seen. Anything you have seen, lambda, either bright or dark. And here you have seen the ratio also. Okay, lambda, 2 lambda, n lambda. And here it starts from 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 2n plus 1 into lambda by 2. This is for bright bands in diffraction. Bright bands in diffraction. These are dark in YDAC. Identi? These are bright and these are dark here. Dark bands in diffraction. Please make a note, chala important idi. Bright, dark, bright vastayi. And also I have explained regarding the light rays coming out from the slit. Okay, clear? Right. Now, let us go to the next item. We have already explained the angular width and other things. Yes. The angular width is also over. Yes. Now, the next one to end up the diffraction is nothing but a graph. So, before going to graph, ఒకసారి మనం values అన్ని మళ్ళీ ఒకసారి రాసుకుందాం. చూడండి. In diffraction experiment you have seen, that is for dark bands. Dark bands. ముందు path reference ఏంటి? lambda, 2 lambda, 3 lambda, 4 lambda, n lambda. Okay? These are things we got. అంతేకాకుండా delta x ఇక్కడ ఎంత వచ్చింది? a sin theta, and this was equal to lambda, and sin theta was equal to lambda by a, or theta angular position for first dark diffraction ఇది bright కాదు, first dark is equal to lambda by a, and this was the difference between any two brights or any two darks. We have obtained already lambda by a. Okay, this is for first dark. అలాగే second 2 lambda, అలాగే third 3 lambda by a, అలాగే third ఇది, అలాగే fourth dark 4 lambda by a. So these are the values for angular positions. ఓకేనా? అలాగే మనకి బ్రైట్ కూడా వచ్చాయి, బ్రైట్ బ్యాండ్స్. బ్రైట్ బ్యాండ్స్ ఎలా వచ్చాయి? ఐ విల్ రైట్ ఇట్ హియర్, అదర్వైజ్ ఎందుకంటే ప్లేస్ లేదు, గ్రాఫ్ గీయాలి. థీటా ఫర్ ఫస్ట్ డార్క్ lambda by a, theta for second dark 2 lambda by a, theta for third dark 3 lambda by a, theta for fourth dark 4 lambda by a, theta for nth dark n lambda by a. Now in the same fashion we have gone for the other ones also. Bright ఎలా వచ్చింది చూడండి, ఇది డార్క్, ఇది డైఫ్రాక్షన్ లో డార్క్, ఇది డార్క్ బ్యాండ్స్. అలాగే బ్రైట్ బ్యాండ్స్కి ఏమొచ్చాయి మనకి? వి గాట్ బ్రైట్ బ్యాండ్స్. వాట్ ఇస్ ద పాత్ రిఫరెన్స్? వి ఆర్ స్టార్టింగ్ ఫ్రమ్ 3 lambda. ఐ టోల్డ్ యు ద డిఫరెన్స్. 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 2n plus 1 into lambda by 2. సో అప్పుడు ఏమైంది ఇక్కడ? డెల్టా ఎక్స్ పాత్ రిఫరెన్స్ a sin theta was equal to what? 3 lambda by 2, or sin theta is equal to 3 lambda by 2a. అర్థమవుతుందా? Therefore, I will start right here. Theta for first bright starting from 3 lambda by 2a. Second bright 3 to the 5 lambda by 2a. Third bright 7 lambda by 2a. Fourth bright 3, 5, 7 9 lambda by 2a. Nth bright 2n plus 1 into lambda by 2a. Why I am writing this one? Put it here, n is equal to 1. 2 into 1 is 2, 1. 2 plus 1, 3 lambda by 2a. Second కావాలి మీకు. Put n is equal to 2 to the 4 plus 1, 5 lambda by 2a. You want third one. Put 3 to the 6 plus 1. So this is the pattern. Now what we'll do is, we'll draw a small graph, very important. చిన్న గ్రాఫ్ గీద్దాం డైఫ్రాక్షన్లో. ఆ గ్రాఫ్ ఏంటంటే ఇట్ ఈస్ ద గ్రాఫ్ వర్సెస్ ఇంటెన్సిటీ I versus theta or sin theta. Okay na? This is the origin. So intensity, and this is angular positions. Okay. Now you can see here. We'll try to graph. Okay. So we already got intensity formula manaku telusu kada. Intensity I is equal to what? K into A square. K is intensity directly proportional to amplitude square. So already maximum intensity మనకి ఎక్కడ వస్తుంది? ఎక్కడ maximum intensity ఉంటుంది చెప్పండి? Origin. Okay, because already I have given a formula for you, 4i cos square 5 by 2, even in light chapter, this chapter, and also in sound chapter. 4i into cos square 5 by 2. When phi is equal to 0 degrees, cos 0 is equal to 1, it is equal to I 4i. So if you draw a graph here, we'll see what happens. మనకి ఇందాక వాల్యూ చూడండి, ఫస్ట్ డార్క్ ఎక్కడ వచ్చింది? లాంబ్డా బై ఫస్ట్ డార్క్. ఫస్ట్ డార్క్, అలాగే సెకండ్ డార్క్ 2 లాంబ్డా బై ఏ, అలాగే థర్డ్ డార్క్ 3 లాంబ్డా బై ఏ. This is third dark. Again in the same fashion right here also, lambda by a, first dark this side. Okay na? We'll give a gap for the bright one. Next one 2 lambda by a, second dark, and last one is third dark, that is 3 lambda by a. Now if you observe, between the dark you are having a bright band. Bright ఎక్కడ ఫామ్ అని చూడండి, bright, first bright 3 lambda by 2a, 3 lambda by 2 here, 3 lambda by 2a, first bright 3 lambda by 2a, అంతేనా? 3 lambda by 2a. అలాగే నెక్స్ట్ వన్ 5 lambda, సెకండ్ ఇది 5 lambda by 2a. అలాగే థర్డ్ if you want 7 lambda by 2a. The same way here you are getting same thing, 3 lambda by 2a, 5 lambda by 2a. That means between two darks one bright is forming now. So intensity here it is maximum. Next you can observe. Okay. Next it is again down lambda by a. నెక్స్ట్ మళ్ళీ ఎక్కడ ఉంటుంది ఇంటెన్సిటీ? 3 lambda by a కొంచెం తగ్గుతుంది ఇంటెన్సిటీ. ఓకేనా? తర్వాత మళ్ళీ ఎక్కడ 5 lambda a దగ్గర ఇంకా కొంచెం తగ్గుతుంది, స్టిల్ లెస్సర్. 5 lambda ఎక్కడ ఉంది? ఇక్కడ 5 lambda స్టిల్ తగ్గుతుంది. అండ్ లాస్ట్ వన్ అగైన్ 3 lambda. జాగ్రత్త చూసుకోండి ఒకసారి ఈ గ్రాఫ్, ఎందుకంటే ఎగ్జామినేషన్ అప్పుడు ఇది కూడా అడుగుతున్నాడు మనకి. సో మ్యాక్సిమం ఇయర్ ఆరిజిన్, తర్వాత లాంబ్డా బై ఏ, ఫస్ట్ డార్క్ అగైన్ ఇట్ ఈస్ డిక్రీజింగ్. ఫస్ట్ డార్క్ ఏమవుతుంది? డార్క్ కదా, డిస్ట్రక్టివ్. వాట్ ఈస్ మెant బై డార్క్? డిస్ట్రక్టివ్. బ్రేకప్ అగైన్. ఓకే, డార్క్ బ్యాండ్ ఫాలింగ్ డౌన్. హియర్ మ్యాక్సిమం. ఈ మ్యాక్సిమం అంటే ఎవరో చెప్పగలరా? సెంట్రల్ బ్యాండ్ అండి, సెంట్రల్ బ్యాండ్ మధ్యలో. This is nothing but central band. 2 times it is. That side and this side. Opposite sides, రెండు side. Angle theta and theta, 2 theta. So maximum you are getting there. So this is at the central band. Okay na? Central band, I will write it here. Central band, CB. Central band మీరు చూసే ఉంటారు గ్రాఫ్లో, ఇటుపక్క యాంగిల్ తీటా, అటుపక్క యాంగిల్ అటు ఇటు ఫామ్ అవుతుంది. అందుకే మ్యాక్సిమం అనమాట. డెల్టా ఎక్స్ ఈక్వల్ టు 0 కదా, 0 అంటే ఏంటి మ్యాక్సిమం వస్తుంది కదా. తర్వాత నెక్స్ట్ ఇంటెన్సిటీ మళ్ళీ ఎప్పుడు వచ్చింది మనకి డెల్టా ఏ తర్వాత 3 λ బై ఏ, 3 λ బై 2a. ఇగో బ్రైట్ ఇక్కడ 3 λ బై 2a బ్రైట్. మళ్ళీ 2 λ బై ఏ డార్క్. ఓకేనా. తర్వాత మళ్ళీ నెక్స్ట్ బ్రైట్ 5 λ. నెక్స్ట్ మళ్ళీ డార్క్ 3 λ. ఇగో 3 λ బై ఏ డార్క్. The same way here also you can see dark band lambda a by a dark, first dark. Again mali 3 lambda by 2a, first bright. Next 2 lambda a by a, 2 lambda by a. Where is 2 lambda by second dark again? Okay na. 5 lambda by 2a, second bright again. And last one 3 lambda by a, again third dark. So this is the graph you are getting for intensity of the light versus theta or sin theta angle. Theta or sin theta. And theta integrate angular positions anamata. Angular positions. So these are the things are given on the right side, and this is the graph intensity decreasing. You can see. Okay. 3 lambda by 2a ki rendu okala untundi. తర్వాత you can see here 3 lambda by 2a. Okay, 2 lambda, 5 lambda. Okay, clear? Lambda by a, 2 lambda by a, 3 lambda by a. ఇవన్నీ ఏంటి డార్క్స్, ఫస్ట్ డార్క్, సెకండ్ డార్క్, థర్డ్ డార్క్. బిట్వీన్ డార్క్స్ యూఆర్ హ్యావింగ్ వన్ బ్రైట్. ఫస్ట్ బ్రైట్ 3 lambda by 2a, సెకండ్ బ్రైట్ 5 lambda by 2a. ఇంకా అలా కంటిన్యూ అవుతుంది. ఇక్కడ కూడా చూడండి, ఫస్ట్ డార్క్, సెకండ్ డార్క్, థర్డ్ డార్క్. బిట్వీన్ 2 డార్క్స్ 1 బ్రైట్. దట్ ఈస్ బిట్వీన్ lambda by a and 2 lambda by a, 3 lambda by 2a. Between 2 lambda by a and 3 lambda by 2a, 5 lambda. You can see between 2 lambda by a, between 2 lambda by a and 3 lambda by a. Okay na? So you can see the values here. Lambda by a, 2 lambda by a, 3 lambda by a. అలాగే మధ్యలో డార్క్ వచ్చినప్పుడు యూ కెన్ సీ 3 lambda by 2a, 5 lambda by 2a, so on. ఇక్కడ కూడా అంతే 3 lambda by 2a, 5 lambda. So like this if you frame, you will get a graph in this. Nice graph you are getting. Intensity of light versus angular positions. Clear? Any doubts? Please make a note here. These are very, very important. Very, very important. Lambda by a. Okay? First dark, second dark and third dark. Okay? Then dark la madhyana mali bright. 3 lambda by first bright. Alage 5 lambda by 2a, second bright. So this is how you can explain the complete diffraction pattern regarding numericals or examination or advanced level. Now I am shifting to the last part, that is polarization of light. Okay, last one, polarization of light. దీన్ని తెలుగులో ధ్రువణం, కాంతి యొక్క ధ్రువణం. Okay, so let us see what is meant by polarization. Very easy one, this one, light polarization. So polarization means generally, see for example, last one, polarization of light. What the last one? Polarization of light. Okay, so how to explain the polarization of light? See, for example, we all know in electromagnetic wave, I told you electric vector is more dominant than magnetic vector. Okay, it is almost, I have given some formula also for you. E naught by B naught is equal to C, or E naught is equal to C into B naught. That means E naught is very much greater than B naught. And the electric field vector is more greater than magnetic field vector. That is when polarization of explanation, magnetic field is not considered. Okay. For example, take this electric field vector light, which is in all directions. You can see symmetry. So light is in all directions. You can see it is symmetry. So this is what? Electric field vector. Into the electric field vector. So light is coming in all directions. You can see all directions. This direction, vertical direction, horizontal direction, this angle. In all directions light is coming. So when this light is coming, this is the direction of wave propagation. Direction of wave propagation. In this direction it is coming. Now we have to obstruct the light rays in one direction. For example, I will give a first one. Suppose this is wave direction. Suppose like this waves are coming. This is light is called a UPL, unpolarized light. You know what unpolarized light. So polarization and enti, when the light is coming in different directions, it is made into only one direction, or vertical or horizontal. Vertical direction oscillation, vibration, or horizontal direction oscillation. So making in that way, that is called as polarized light. Now here this light is UPL, unpolarized. You can see in different direction light is coming. Suppose if you are making in this way, this is also UPL, this is also unpolarized light, but here you are having only two. One is vertical electric field vector, another one is horizontal. Okay, vertical direction perpendicular to the wave propagation, horizontal direction, only these two are there, this and this. So these two indicates this is the symbol, two arrow marks, middle dot. Suppose if you are indicating in this fashion, here horizontal is there, horizontal, this direction, vertical is also there. Suppose here only dots are given, then only horizontal electric field is there, no vertical. Here only horizontal. Only horizontal electric field vector is there. Here no vertical. Vertical electric field vector is there, not there. Only horizontal is there. Only dots are given. Dots and line is given. Arrow marks means horizontal vector is there, electrical vector, vertical electrical field vector is there. So this is how you have to indicate. And this is also unpolarized light with only two, vertical electric field vector and horizontal field vector. Clear? Right. Now we will do some experiments how the light is polarized. Okay, by using some polarizers. Now we have some polarizers or polaroids. Like you can see, this is a tourmaline crystal. This is called as first one, tourmaline crystal, which is used as a polarizer crystal, or sometimes Nicol prism. Either tourmaline crystal, in chemistry it will be using tourmaline crystal. These are specially made, used as a polarizers or polarizer. They will be filtering the light. For example, if I use a polarizer like this, this is the polarizer P. Now suppose this is the passageway, this direction. This is what? Passageway of light. So what does it indicate? This unpolarized light in different direction will try to come, and only these vertical directions, you can see, remaining all will stop. Only this vertical direction of light, electric field vector, will come outside. Only vertical in the sense, even the components will be there. These components. Okay, vertical component will be there. Suppose if the amplitude of the light wave is suppose A be the amplitude. Okay, and for example, I is equal to We already know A into K into A square. This is the formula already I told before. Suppose here you are having maximum intensity, say maximum. And for example, say I naught is equal to K into A square, where I naught is maximum value, maximum amplitude. Now when it is coming here, what happens? Remaining all will be obstructed because of the polarizer, polaroids, like tourmaline crystal or nickel. Only the component of vertical will be coming outside. And enti ivi matram bayatiki vastayi. See here? This light is called as polarized light. This light is called as polarized light. Suppose if you are indicating in this way, then it is also called as PPL. That means only horizontal electric field vector will be there, no vertical. So here only vertical is there, horizontal is not vertical. So of course it is polarized light. This light is polarized. That means whatever intensity was there, it was reduced to half. So suppose intensity before it was I0. Now it is becoming I0 by 2. The maximum intensity, because only the vertical component, see, the vertical component, the vertical component, the vertical component, the vertical component, okay, that is A sin theta, vertical component. Only those will be passing from the passes of the crystal. Remaining all will be obstructed because of the polarizer. So such type of light is called as polarized light. And this is the direction of the wave. So before it was intensity I0, it becomes I0 by 2. Clear? Right. Now, we will try to do one more experiment and try to explain this subject, polarization. See here. Same tourmaline crystal is used as a polarizer. Now we will use two polaroids. For example, this light is coming in different directions. Okay. Sometimes partially polarized is also taken. Partially polarized. See, partially polarized entire, for example, like this. Vertical, horizontal, that's all. Over. So these are partially polarized. I mean partially అంటే ఇది కంప్లీట్ గా ఇది కూడా unpolarized light. ఇది కూడా unpolarized. This is also not partial at least, sorry. But light rays are reduced here. This because you can see it is completely symmetry here. It is not completely symmetry. Okay. So you have taken vertical, horizontal and two another components here. So this is also of course UPL. In this case also if you pass on with a polaroid P1, what happens if the passes, for example, passes light. So what happens, passes only these components and entivi horizontal, A cos theta, only those will come outside. See here, A cos theta, that means this polaroid is kept at some angle theta. So after then components matram vastayi horizontal, A cos theta will come outside. That means you can increase the value of the intensity or you can decrease the value of intensity by using the polaroids P1 and P2. Okay, even you can use two polaroids. First polaroid, second polaroid also. See here, first polaroid, second polaroid, you can increase or decrease. చూడండి ఇప్పుడు లైట్ రేస్ ఇలా బయటకు వచ్చింది కదా, పోలరైజ్ లైట్ ఇలా వచ్చింది చూడండి. ఇప్పుడు ఇంకో పోలరాయిడ్ యూజ్ చేసాను P2 by rotating it. For example, now the vertical component is coming, electric field vector. Now what happens if you rotate by 90 degrees completely? Rotate చేస్తే ఏమవుతుంది, ఈ మొత్తం ఇవన్నీ వెర్టికల్ అన్నీ ఆగిపోతాయి. 90 degrees చేస్తే ఏమవుతుంది, వెర్టికల్ మొత్తం ఆగిపోతాయి. So sometimes the intensity is becoming to 0 or intensity is maximum. So by using polarizers or polaroids, sometimes you will be using in sunglasses, polarizers, polaroids, when you go outside in summer. So those glasses, what happens, it will prevent the sun rays coming in all directions, and it makes it only in one direction, either vertical or horizontal. So that is why those sunglasses or goggles, okay, cooling glasses, this will reduce the intensity of light. in whichever direction you want. So intensity is increased or decreased here. You can observe from this experiment. Are you following here? Now what I will do is I will tilt with some angle now. కొంచెం యాంగిల్ మారుస్తాను ఇక్కడ నేను. I am tilting this one. This is the first polarizer. For example, unpolarized light is coming. This is unpolarized light. First polarizer, P1. So from this I told you vertical will be coming outside. Okay? Vertical will be coming outside. Let the value be amplitude A. That is amplitude of the wave. Vertical direction, no horizontal. A is there. Now for example, the passage I will change now. I will change the passage. Suppose this is another Polaroid, P2, P1, first Polaroid. Now for example, the passage is like this. And అర్థం ఏంటి? This Polaroid is kept at an angle in this fashion. For example, this is vertical, y dash. So the passage is like this. This is the passage and along the Polaroid. So what is this component? This is having A amplitude. So what will be this component? A cos theta. Vertical ki theta angle పెట్టాం. So what is this component? Okay? A cos theta. A cos theta. A cos theta. This is the direction of wave. Direction of wave. So whatever waves are coming, what? Here you can see. Only the components are coming. Remaining all are obstructing. And ఇక్కడ ఏమొస్తాయి? Only A cos theta components are coming. Only these components. A cos theta, A cos theta. Now for example, initial intensity was A. I mean I0. And already I have told you I0 is equal to K into A square. Now it is coming out. What waves are coming outside? The components horizontal are coming outside because of the passageway, second polarizer. So what ఏమవుతుంది మనకి? Now the intensity here coming out is equal to K into A square from the formula. So I is equal to K into, what is A here? Component A cos theta whole square. Therefore I is equal to K into A square cos square theta, or I'll write it here. I is equal to, what is K A square from equation 1? I naught. So I naught cos square theta. This is called as Malus law. Very, very important. Malus law. Okay? So Malus law ఏమవుతుంది? When the passageway is reduced, I mean kept at some angle. So the components, if intensity was I0 initially, amplitude initially was A, when it is passing through some angle, the component will be coming out from the Polaroid. That is A cos theta. And the intensity is reduced to I is equal to K into A square. That is K into A cos theta whole square. That is finally you will getting as K A square cos square. That is nothing but I is equal to I naught cos square theta. That is called as Malus law. Very, very important the examination point of view. Okay. Now let us go to the next one. Uses of Polaroids. So just now I told you what are the uses. By using Polaroids you can reduce the intensity of light and make it into one direction. And it is protecting the eyes from UV rays. Many uses are there, Polaroids. Okay. If you don't want the unwanted light rays, that also can be reduced by using the polarizers or Polaroids. Okay. So main uses ఏంటి? Polaroids it gives cooling for the eyes, and it can reduce only in one direction light rays. Okay, మీకు ఏ డైరెక్షన్ కావాలంటే ఆ డైరెక్షన్లోనే మార్చుకోవచ్చు, either this direction or horizontal. So intensity of light is coming in all directions. That will be reduced to one direction. So by using polarizers you can reduce the intensity, UV rays and other thing, and it is also protecting the eyes. Now the last topic we are left over is Brevister's law. Last topic to end up this chapter, that is Brevister's law. Brevister's law. Okay, and also reflection of polarized light. Polarized light. For example, this is a normal separating two media. One is air, one medium is air, whose refractive index is 1. Second medium, you can take any glass glass medium or water. Glass or water. Glass medium because it's transparent. Water is transparent, and you can take glass. Okay? Glass medium or water. Both are transparent. Glass medium. Let the refractive index be mu. Let the refractive index be mu. Okay? That is refractive index of glass. Now, suppose the light is entering in this fashion, hitting with some angle I. Now, here I will take the light in this fashion, place here. I told you before also, when I am putting two arrows and middle dot. So, here what happens? Only vertical electric field vector and horizontal is there. Only vertical, not still it is UPL, unpolarized light. Now it is incidenting, reflected, and some light rays is refracted. Now here what is happening is, see, this is refracted light rays, still it is UPL, still this is UPL, unpolarized light. And some light rays, what happens, it will go in this fashion. Only horizontal electric field vector is there, and also somewhat vertical is also present. It is reflected. And suppose if you go on increasing the value of incidence in the error medium, at one particular angle of incidence, when I is equal to IP, called as polarizing angle. When I, at a particular angle, if you go on increasing the angle, at a particular angle of incidence, I is equal to IP, at a polarizing angle, what happens is, this vertical component, vertical field vectors, electric vectors, will completely go away. Only horizontal will be there. Mottam chudandi. Okay? This is also called a plane polarized light. Inka etuvanti vertical leave, only horizontal is here. Only horizontal vibration is there. Vertical leave, only horizontal unnai. This is also called as plane polarized light. Plane polarized light, PPL. Okay? Ila vertical direction leave, only horizontal direction light will be there. Electric field vector. At what time? At what point when I is equal to IP? In such cases, the reflected angle and refracted angle makes 90 degrees. The angle between reflected light, polarized light, and here, refracted one will be 90 degrees. Okay? And that is called as Brevister's law. Okay? And when light is incidenting with the normal for polarizing angle IP, the reflected angle, the reflected light ray and refracted light ray both are making an angle 90 degrees. The angle between reflected and refracted light is 90 degrees. That is called as Brevister's law. Now let us see some equation. At that point, this is angle I is equal to IP. Then from loss of reflection or refraction, IP, reflection kuda IPA. From loss of reflection, angle of incidence is equal to angle of reflection. So IP is equal to IP here. And this is 90 degrees. And this is R, refraction angle. Now we'll apply Snell's law here at this point. Snell's law. Okay? Snell's law at a point of incidence. At a point of incidence. What is Snell's law? Sine angle incidence in this medium. Snell's law em cheppanu? Sine angle incidence in this medium. Sine angle incidence ante sine incident ante IP in this medium. The refractive index of this medium, air, is equal to sine angle refraction in the second medium into the refractive index of that medium, that is mu. Therefore, sin IP is equal to sin R into mu లేదా sin IP by sin R is equal to mu. Now let us calculate what is R here from geometry. Now you see from laws of reflection ఇది IP ఇది 90. So ఈ యాంగిల్ ఎంత అవుతుంది చూడండి మొత్తం 180 degrees. Please make a note here. What is the total angle here? What is this total angle? 180 from geometry. So ఈ యాంగిల్ కావాలంటే total angle 180 minus IP plus 90 or 90 plus అవి ఏదైనా ఒకటే ఓకేనా IP plus 90 degrees. మీకు అర్థమవుతుందా ఈ యాంగిల్ ఏంటి దిస్ యాంగిల్ ప్లస్ దిస్ యాంగిల్ 180 minus IP plus 90 is equal to small r refraction angle. So 180 degrees minus IP minus 90 is equal to R. 180 minus 90 that is 90. 90 minus IP polarized angle is equal to R. Equation 2. Put this value in the place of this R. So when you put that value, what happens? I am rubbing this figure now. No need of figure this one. Okay. So now what happens mathematically from Snell's law? Sin I P by sin R. What is R here? 90 minus IP. 90 minus IP is equal to mu refractive index of the medium, second medium. So sin IP, sin 90 minus theta, first quadrant, cos theta. Therefore, cos IP is equal to mu. So sin IP by cos IP and tan IP. So tan IP is equal to mu. This is of course again Brevister's law. లేదా Brevister's polarizing angle. లేదా IP polarizing angle is equal to tan inverse mu. So this is the mu value refractive index of the second medium, transparent medium, whatever you use. This derivation, this formula is very very important for the numericals. Please note down. Clear? Right. Clear all of you? Any doubts? You want to do any problem here? Numerical problem? So we will do one problem and stop. Refractive index of water is given by 4 by 3. Okay? Refractive index of air is given as 1. Of course we know. This is refractive index of water. Now the question is, find IP, find polarizing angle. Okay? So we already know from the Brevister's law, tan IP is equal to mu. Tan IP is equal to mu. And what is mu here? Refractive index of water and air is given. Here refractive index of water and air is given. Kada? So I can write tan IP as like this. Tan IP is equal to mu. And the water the 4 by 3. Refractive index of water and mu 2 by mu 1. Okay na? Air delaga 1 hai kada value. How can you write like this? See, what is mu 2 1? Mu 2 by mu 1. Refractive of the second medium with respect to first medium. Okay na? So tan IP is equal to 4 by 3 or IP is equal to tan inverse 4 by 3. Many times I told you it's a famous triangle. 4 by 3 tan and 4 by 3, this is 5. Pythagorean triplet. So if this is the case, what is this angle? 53 degrees. In kinematics, one dimensional umbrella problems I told you. 4, 3, 5 triangle, 53. And this will be 37 degrees in umbrella problems. So what is IP here? IP, polarizing angle anta 53 degrees. So this is how you have to solve the numericals in by using Brevister's law. Very very important and this is the almost end of the chapter, wave optics or physical optics. Again we will be meeting. Please practice well whatever concept I told you now. Okay, then only you can do the MCET or NEET problems. Again we'll be meeting in the next chapter, that is electrostatics, and that is in that part 1, first part we will be dealing about electric charges and fields in the next chapter.